In this tutorial, I'm going to discuss one-tail and two-tail tests. We set this up by drawing a normal bell curve. And the bell curve represents 100% of all possible events. Right in the middle is the population mean, and we use the Greek letter mu. It looks kind of like a U, but we call it mu. A sample mean can be anywhere within this green area. For sample mean, I use the notation x bar. The value of the sample mean can be above the population mean. It can also be below the population mean. And there's a probability that it will show up somewhere. The sample mean will be somewhere in this green area. With a one-tail test, there's some probability that the sample mean will be in the green area. And I'm going to use a 95% probability. And that means there's a 5% chance the sample mean will show up in the red area. This red area is often known as alpha, the Greek letter alpha. Also, it can be used as the p-value. It's typically called the rejection region. The sample mean has to show up in the red area or in the green area because these two add up to 100%. In this example, I'm using a 95% confidence, and you could actually use any level you wanted to. I can also have a one-tail test with the red area to the right of the population mean. There's a 95% chance a randomly selected mean will be in the green area, sample mean. There is a 5% chance it will appear in the red area, a randomly selected sample mean. But there is a 95% chance it will be in the green area. Again, the red area is often called alpha, referred to as alpha or the p-value, and we refer to it also as the rejection region. Now, when I create a two-tail test at a 95% level of confidence, I will take that red area and I'll put half of it to the right and half of it to the left. In other words, I take alpha divided by 2. So I take the 5% divided by 2, and I put 2.5% on the left side and 2.5% on the right side. You'll also see this alpha divided by 2 in other statistics formulas, and this is what it's referring to. There is 2.5% on the left and 2.5% on the right. 2.5% plus 95% plus 2.5% equals 100%. This means all observations and all events are covered. There is a 95% chance the sample mean will be in the green area, a randomly selected sample mean. There is a 2.5% chance the sample mean will be in the bottom tail. And there's a 2.5% chance the sample mean will be in the upper tail, right there. Now at a 95% level, there's critical values, and these are z-scores, negative 1.96 on the left and positive 1.96 on the right. When I return to a one-tail test, the critical value on the right is a positive 1.645, and the critical value to the left would be a negative 1.645. And this has just been an introduction to one and two-tail tests, and there's more to come, more to learn about stats.